Hello everyone, this is Marcelo from PNCC. In today's tutorial, we'll go over how to set up a data collection on Lacey grids using EPU. For this demonstration, we'll use a smaller atlas collected with just 4 tiles, which will be enough for what we need today. Once your atlas is ready, go to EPU tab. Under Session Creation, click New Session. EPU will ask if you want to use previous preferences. Let's click No so we can start from scratch. The first step is to name the session. At PNCC, sessions are named using the project number, sample name, date, and data. Next, select the grid type that matches your sample. In this example, we're using a Lacey carbon grid. For the session type, select Manual. For the output folder, choose Offload Data. Then click Apply. Now, under Square Selection, click Unselect All, and let's choose a few squares manually. To select a square, right-click and choose Select. To unselect, right-click and choose Unselect. Alternatively, you can hold the Ctrl key on your keyboard and left-click to select a square, or hold Shift and left-click to unselect. Alright, now we are ready to select a couple of squares together. I'm holding Ctrl, then left-clicking here and here. Now we can see square 1 and square 2. The Show option is enabled, so we can see the collection order displayed directly on the atlas. You can toggle these on or off at any time. If you turn on the Change option, you can also modify the acquisition order simply by left-clicking the squares in the desired sequence. Great! Now, right-click and select Move Stage to Grid Square. The red cross indicates the current stage position. Once the stage is ready, we can move on to Area Selection. The first step here is to click the Autocentric button. As soon as EPU finds the eccentric height for the current square, we can go ahead and generate the pattern of acquisition areas. Click Generate, and EPU will draw a hexagonal pattern of acquisition areas across the entire grid square image. This pattern is created using a 5 micrometer spacing, which in this case results in 127 acquisition areas. In other words, the 5 micrometer spacing refers to the center-to-center distance between adjacent acquisition areas. Each acquisition area can display 2 visual elements depending on the microscope configuration. The square represents the detector area, which is the area captured in each recorded image. The circle represents the beam diameter, showing the total area illuminated by the electron beam during image collection. In this example, the beam size is much larger than the detector area, and this is fine for a Lacey grid. However, if you want to adjust the beam diameter, you need to do that in the Data Acquisition preset. Okay, in this first example, the acquisition areas are spaced too far apart. Let's adjust the spacing and generate a new pattern. This time, we'll try 2 micrometers. Perfect. This new pattern gives us almost 800 acquisition areas. Of course, many of these points fall over the grid bar, and we definitely don't want to collect data here. To remove those locations, click the Remove Areas Close to Grid Bar button, a very convenient feature. Alternatively, we can click the button again to toggle it off, and instead refine the selection using the Filterize Quality tool. Depending on your screen resolution, this panel might not be immediately visible. If that's the case, simply minimize the histogram and image information panels and it should appear. Now, if you drag the red slider on your left, you exclude acquisition areas that are too dark, for example, targets over the grid bar, regions with thicker ice, or in this case, areas with excessive carbon, since we are working with a Lacey grid. This way, you might also exclude regions affected by transfer contamination. If you drag the red slider on the right, you'll exclude acquisition areas that are too bright, such as empty holes or areas of very thin ice. After every adjustment, the ice quality filter immediately updates the selection of suitable acquisition areas. Once the sliders are set to your liking, You can combine the results with the remove areas close to grid bar function. This is especially useful since locations near the grid bar tend to have a higher probability of crystalline ice formation. We can also make manual adjustments using the selection brush. This way, you can remove targets by left-clicking and dragging the mouse. Alternatively, you can hold the Ctrl key, then left-click and drag to add targets in specific areas. Alright, now we're ready to click Prepare All Squares. When we do this, EPU will automatically move the stage to the next unprepared grid square. It will first determine the eccentric height for that square, then capture an image, detect the holes, in this case a pattern spaced by 2 micrometers, remove areas near the grid bar, and finally apply the ice quality filter we just defined. Let's give it a try. Click here. And now, a new pattern of targets has been generated according to the parameters we set earlier. But if you're not completely satisfied with the filters applied, you can always go back and adjust them. Likewise, you can use the selection brush again to fine-tune specific targets. Okay, it's important to note that any manual adjustments made this way only affect the current square, not those prepared earlier. However, if you click Redo Preparation, the updated parameters such as spacing, remove areas close to grid bar, or filter thresholds will be applied to all the re-prepared grid squares. Alright, we can now define the minimum stage settling time and the image shift delay. The image shift delay is especially useful to adjust if you observe too much drift during image acquisition. Let's set it to 1 second, for example. Next, let's configure autofocus. Here we can choose how often it runs and which method to use. We'll select Always, meaning autofocus will be performed at every foil hole, and we'll use the objective lens instead of the stage Z-axis. As for the defocus list, we have a notepad with a set of defocus values. Select the desired defocus range you want and paste it in here. We are all set now. We have 2 grid squares prepared, each one with its own eccentric height. We can now move on to the automated acquisition task. If your microscope includes an energy filter, you can enable the auto zero loss routine and define how often it runs. Let's set it to run every 2 hours, for example. The close column valves option is enabled, which means EPU will automatically close the column valves either when the session finishes or if you stop it manually. Alright, we're ready to start the run. In this tutorial, we prepared 2 grid squares and selected nearly 300 targets for acquisition. Because this is a Lacey grid, the first target is used only as a sacrificial area for autofocus. That's why every time we click Start Run, the first exposure will be automatically skipped. EPU will then move to the next location and capture an image. As soon as the image is recorded, it will perform another autofocus routine at the same position, since we selected autofocus to run on every foil hole. While autofocus is running, you may notice some being induced damage across the area as a result of cumulative electron exposure. But don't you worry and remember, EPU will first move to a new location, apply the desired defocus, and then capture the next image. After that, it will continue the autofocus routine according to your settings. And now, just sit back and enjoy the ride as the data collection goes on. And that's it for today. Thank you for watching this tutorial. If you found it helpful, please like and subscribe. Also, feel free to leave a comment below with your questions or requests for future videos, and we'll be happy to answer them.